Hello Flutterlings, welcome to this comprehensive introduction to the Dart language. Today we will walk through its main features using practical examples. So if you are looking to get a solid understanding of the Dart language, you have come to the right place. For more detailed Dart language topics, visit Dart official language page. And if you are interested in Dart's core libraries, be sure to check out the library tour. Let's get started with a simple Hello World program in Dart. Here is how you do it. Void main, print Hello World. In Dart, every application begins with the main function. This is where execution starts. The void keyword denotes that the function doesn't return a value. To output text to the console, we use the print function. Dart offers dynamic typing, meaning you can declare most variables without specifying their type explicitly, using the var keyword. The types are then inferred from their initial values. Let's see an example. As you can see, Dart's type inference feature is able to determine the types of each variable based on its initial value. Control flow statements. Dart supports common control flow statements like if, else, for, and while loops. Here is how they are used in Dart. These statements allow us to control the flow of our program based on specific conditions. Dart encourages the types of each function's arguments and return value. Here is an example of a recursive Fibonacci function. Dart also provides a shorthand syntax for functions that contain a single statement, which is particularly handy when passing anonymous functions as arguments. Comments in Dart usually starts with /. Here is how you can comment your Dart code. Comments are essential tool for documenting the code and improving its readability. To use APIs defined in other libraries, you can use import keyword. Let's look at how to import core libraries from external packages and specific files. Dart, being an object-oriented language, supports classes. Here is an example of a class named Spacecraft with properties, constructors, and methods. And here is how you would use the Spacecraft class. Classes in Dart offer a robust set of features to support object-oriented programming, and we will delve deeper into these in the following sections. Enums are a way to define fixed set of values, and we can ensure that there can't be any other instance of that type. We will use our cosmic theme to demonstrate this. Let's say we want to categorize planets into types. We would create an enum called planet type. We can use these in an enhanced enum that contains additional properties. Here's an example where we can define planets in our solar system with some of their properties. Let's move on to inheritance. Dart supports single inheritance, meaning a class can inherit properties and methods from another class. For instance, we could define a new orbiter class that extends our previous spacecraft class. The orbiter class now has inherited the properties and methods from the spacecraft class and additionally has an altitude property. Next up, Mixins. They allow us to reuse code across multiple class hierarchies. Think of them as a set of methods that can be used in different classes without needing inheritance. We can create a Mixin named piloted. Then we can include this Mixin in our spacecraft class using with keyword like this. Now The piloted craft class has access to the methods and properties defined in the piloted Mixin. Now, let's explore interfaces and abstract classes. In Dart, all classes implicitly define an interface. You can implement this interface in other classes. For instance, we can create a mock version of a Spacecraft class. Dart allows the use of abstract classes. An abstract class is a class that cannot be instantiated directly. Instead, you create subclasses that implement the abstract method of the abstract class. In the describable class, describe is an abstract method and describe with emphasis is a regular method that uses the describe method. Moving on to asynchronous programming. In Dart, you can make your code more readable using async and await. These keywords allow us to write asynchronous code in a way that looks synchronous. Here, the print with delay function waits for 1 second and prints a message. The await keyword ensures the Dart pauses execution of the function until the future completes. Lastly, let's talk about exception handling in Dart. Try, catch, finally blocks handle exceptions. The try block encloses the statement that might follow an exception. The catch block catches the exception and handles it. The finally block contains the code that is always executed regardless of whether an exception was thrown or caught. In this function, we try to read content of a file. And if an IO exception occurs, we print a message and then clears the list of objects, irrespective of whether an exception was thrown. And that's a wrap on the quick tour of Dart. This only scratches the surface of what you can do with Dart. That's it, Flutterlings. And on the coming videos, we will be digging more deeper into each and every topic and concepts related to Dart. So until then, thank you for tuning in and see you in the next tutorial.